let's say, I mean, y'all want to just give me a polyatomic anion? Anybody? What? Did you say ammonium? Ammonium. Okay. NH4. What? I don't know what you said. You didn't say ammonium, did you? What did you say? Aluminum?
Yeah, but then you said polyatomic.
Oh, right. Aluminum's not a polyatomic. Am I going to cover it? No, it'll stay visible for you guys.
Elements of the category.
Are you going to have to put their elements in their... I mean, anything that I've talked about is fair game for the exam. So sure, I could ask you which elements are alkali or earth. We've talked about that, so I definitely want you to know that information. Main group 3, boron and everything under that is main group 3. Carbon, come on in, you're in the right spot. Carbon, everything under carbon is main group 4. Then yeah. All right, so Pablo said ammonium. No, he didn't, but we're pretending he did. And then let's say we have an anion of chlorine. Okay, I wrote the charges on there. I was nice to you. Can we write a compound with that cation and that anion? How would you do that? Huh? We would need 4 CLs. You need 1? I swear I heard somebody say you would need 4. Right, okay. So when these come together, it's just going to be NH4Cl. Why? Yeah. Right, I just write a plus and a minus usually if it's 1, but you could write the 1 in if that really helps you or you need it. Okay, so just come on, let's do something harder than that. Because you know I'm going to go harder than that on the exam, right?
What if there was a charge, charges were like an actual number? Would it be
an actual number? So 1 isn't an actual number? I'm just kidding. Something harder than 1, right? That's what I'm saying. Let's do something harder. Okay, so I'm going to give you. We did that one in lecture though. True, that's a good thought because the numbers are different. Let's do this. Let's do calcium and hydroxide. I'm not writing the charges on there for you. What would calcium be? Pablo, you can't answer. Huh? +2? How do you know that? Because Pablo said so. Because it's in main group 2. See, this should not be rocket science. You guys should know exactly how to do this, okay? It's in main group 2, which means it has 2 valence electrons. Everything in main group 1 and main group 2, anything that's a metal is going to lose its valence electrons, okay? And become a cation that's positively charged. So it's going to be a +2 when it loses those 2 valence electrons. Okay, what charge does hydroxide have on it? -1. You have to know this. Yesterday. The charges? Sorry, explain the charge on which one? OH? That's just rote memorization. Okay. Seriously, like there is an explanation, but I'm not going to get into it. Okay, you just memorize. Hydroxide has a -1 charge. Okay, so when we put these together, what's our compound? Right, because if you don't do parentheses, it just looks like you have 2 hydrogens. You need 2 hydroxides, and it's a polyatomic, which was our 3rd rule right here.
Oh, right, that every polyatomic needs parentheses around it because there's more than 1.
Right there. Number 3. Use parentheses around the polyatomic ion formula if it has a subscript. We need 2, so that's a subscript of 2. So that's why right here, I've got to have parentheses with a 2. Sounds a little more challenging. I like it. All right, I'm gonna do a really hard one. Oh, it could be 2 polyatomics. Ammonium carbonate, ammonium phosphate.
Wasn't there like an issue if we had a polyatomic with a subscript in the beginning of it with parentheses?
There's no issue. It's just you have to be aware it's the cation. That's what she was just, sorry, Grace, right? Was just getting at, is let's say we have, you're very limited on your polyatomic cations. You got hydronium or ammonium. And I really don't get into hydronium until we hit acids and bases. So it'll probably just be ammonium. Okay, NH4, and let's do phosphate, PO4. What are the charges here?
+1.
Kevin said plus, and what's phosphate? -3. All right, when these come together, what do we get?
So could we not do NH4 close parentheses 3?
Yeah, why can't we?
Okay.
You need 3 of them, right? So that's what you got there.
4 is just 1.
Yeah, you just need 1 of them, so we just write PO4.
Okay, yeah. I'm not sure if we were allowed to put that many numbers up there.
Does the anion, the negative charge, does it always drop?
Does the negative charge always drop? What do you mean?
Like -3, it switches to +3. Like is it always?
-3 switch to +3, where?
But that just means that there's 4, or that there's 3 of the NH4s. It doesn't mean that that's a positive.
So the negative charge doesn't matter?
No, it matters.
But you got rid of it there too.
Okay, got rid of it, like, when I'm writing that, let's go back to our rules. When we write the compound, do not include the charge on the ion. We just write the symbols for the atoms and any subscripts, which are the smaller numbers at the bottom, telling us how many of that atom we need, or it's an ion in this case, in our compound, right? So it's not that we're losing the charges. The charge is very much still there. We just don't write it in.
Okay, that's my question.
Yeah. No, this is still a -2 charge, and that's still a +2 charge. It's understood. Okay, when we write the compound, because the compound is a neutral unit as a whole. So we want to view it on paper as a neutral unit. But you have to understand if they're together, they're ions. 'Cause otherwise, they're not attracted to each other. There's no reason for them to come together. Okay.
Can you do, I don't know why, anyways, can you, do one that's already a compound and then for practice, like we can break it up? Like kind of
Like name it and write the ions. Sure.
Yeah.
Sure. I know it does. Any reason to get people together and do chemistry is delightful. Okay, sure. Let's go with well, okay, sorry. You want me to write? Let's do. Okay. So write the name of that. So I will give you a periodic table that has the names, not just the symbols, because you're not going to get the name off this one. So if you have one in your notes, you might want to pull that out. Cu parentheses HCO3 with a 2.
I don't know how to put it together. Words not make
Look at there.
They have 2 valence electrons already, so maybe we can put it where it's giving.
Okay, so you should have it by now. Anybody got the name of it? Tatiana.
Copper 2 by carbonate.
Copper. And how did you write 2?
The Roman numeral.
Roman numeral 2, bicarbonate. That's right. So copper is a transition metal. How did you know it was copper 2?
The 2 on the
Yeah, what about it? The 2, she said the 2 on the polyatomic told her that there was going to be a 2 here on copper.
To switch it back.
So you unswap the switch trick. Is that what you're doing? That's fair.
But if we were writing it out, it would be like Cu plus 2. and then-
So, but Cu, oh, if you're writing the ions, yeah, this is a Cu2 plus charge and HCO3 with a minus, and you have 2 of them. I put a 2 out front. This is called a coefficient. That just means there's 2 of these things.
Oh.
But you don't have to, okay, if I just said write the ions, you wouldn't write that 2. You would just write the ions. I'm just showing you in the compound, there's, I'm on eraser still. There's 2 of these,
Now there's 2, yeah.
right? So that's why I put a coefficient, but you don't have to write, if I just said write the ions, write 1 each.
Can you do another one like that?
Yeah. All right. Let's do, write that. Also write that.
Is this all right?
I don't want to say it out loud if you're wrong. So I'm gonna read it.
Say it out loud. No, that's not right.
That's why I didn't say it out
There's
loud.
a few things wrong with it. There's more than one thing wrong with it.
Oh. I read that wrong. I wrote it down wrong too.
Somebody who's got it, raise your hands. Okay, if you've got it, look down at your desk.
With a periodic table, like the name,
Do what?
with a periodic table, we have to have a name.
Yes. So you'll have one just like, I don't want to flip right now, but I showed y'all a picture of exactly one you would have in lecture. Exactly, exactly. So you should have one from your lecture notes. You could actually, and if you go through the lecture notes from chapter 3 ionic compounds, I guarantee you there's one in there towards the bottom.
Yeah, period.
All right, Julia. Oh, look at her. Yeah, sorry. I didn't finish that. Okay, what's the first one? Na2CO3. Sodium. Why isn't it this? Not a transition metal, and sodium doesn't have a +2 charge. Okay, this number right here doesn't tell you the charge on that. That just tells you how many sodiums are in the compound. Only for transition metals. Sodium carbonate. And then Julia corrected me. I wrote the wrong formula.
Okay.
I won't do that on the exam, I promise. Although I have made mistakes on exams before. What is this last one? SrNO3. Strontium. Did I spell that right? Strontium.
Yeah.
And then nitrate. Okay, no Roman numerals here because strontium is a main group cation, not a transition metal. Is it starting to make sense? I think this was probably the most challenging because we just did it yesterday. So
Is the test gonna be like open response like that? Or multiple choice?
you'll have probably 10 or 12 multiple choice, and then you'll have some where you open response.
How many are there?
Well, if I had the exam written, I would tell you. I have plenty I could pull from.
So you said that the NO3 wouldn't have any Roman numerals because it's a main group ion?
Do what?
Well, okay, the reason they said that the NO3 would have Roman numerals is why?
NO3? NO3 is a polyatomic. Polyatomics never have Roman numerals. Yeah, do not go putting Roman numerals on everything. You only put Roman numerals for transition metal cations. And you'll never have a transition metal anion. So it's just transition metals. And they're only ever cations, okay? Which ones are the transition metals?
In the middle.
Yeah, it's this block. There's a picture in our chapter two lecture slides, atomic atoms in the periodic table. There's a picture where this block starting here, okay, all of this is colored in blue. And I said the blue block. And we labeled that the transition metals, okay? That picture I think is the best help, and that's in your lecture slides.
And everything to the left of the staircase is in metal. Question.
Now I gotta go find it. What?
Yeah. And then the.
There, transition metals are in blue. Okay, those are transition, and then what?
Everything to the left of the staircase is metal.
Everything to the left are metals, yeah.
And then the non-metals are.
Well, a couple of those are metalloids like germanium, but I think germanium is actually a metal. Okay. All right, somebody said they had a question about the lab.
Yeah.
Okay, which lab questions did y'all want to go over? 7 and 8?
And 6.
Y'all killing me. So I'm gonna start with the one about the 180-pound man. All right, I think that's number 5. This problem says you have a 180-pound man, and it says he takes a dose of toxic cleanse, and 1 dose is how much of the drug? 1 dose, you need to write this down, is 325 milligrams of the drug, which is the toxic cleanse. He weighs 180 pounds. Okay, look at your paper if you have it and read this with me. In the next sentence, it says, calculate the man's dosage. And then it says in, somebody read to me what it says after that. It says, calculate the man's dosage in what? So a dosage is this. It is milligrams of the toxic cleanse, I'm going to abbreviate, over kilograms of body weight. That is a dosage, and a dosage has those units, okay? So you need to find his milligrams of drug that he took. The problem tells you that. And you need to find his body weight in kilograms. And then all you do is divide. You're not trying to cancel units. You're not trying to plug in and cross multiply and rearrange an equation here. You're just plugging in his milligrams of the drug, his body weight in kilograms. You're given his body weight just in pounds. How do we convert that to kilograms? That relationship is on page 1. It's 0.454 kg equals 1 lb. So you'll take 180 pounds, convert that to kilograms. Okay, I'm not going to write that out for you. Get his weight in kilograms, you plug it in right there on the bottom, and the problem gives you his milligrams of drug. Okay, that's it for that one. No, that's given to you on the front page. So you're comparing to those. It says, so the last sentence there, once you calculate his dosage, it says, compare to the listed ED50 and LD50, which are printed on the first page for you. The ED50 is 6 mg per kg. The LD50 is 18. You're going to calculate his dosage and compare it. What can you say about his number, his dosage compared to the effective dose and compared to the lethal dose? I'm gonna skip number 6 because you do it the exact same way as you do number 5. But with the toddler who does not weigh 180 pounds. That would be a toddler to see. Ask your,
Milligram like it does on number 5.
what?
I said it doesn't give us the.
What does it say? It says a mom decides to give her fussy baby, yeah, a dose. Right, which is why you are writing out this relationship. That's really important for now. One dose is 325 milligrams for the rest of the,
Okay, I didn't know they were.
yep. Huh?
I don't know. Let's try.
Okay. All right, so that's 5 and 6. We'll calculate the toddler's dosage, compare it. God, does that say 74? Is this room on 74? Golly. Hot. All right, question 8. We skipped 7. Y'all want, let's do 7 then 8. 7, we are trying to calculate a weight in pounds for a person to receive an effective dose, and then for one dose to be lethal. So 7 has parts A and part B, okay? So 7A. So if you read this problem, what it's telling you is it says use the ED50 and the LD50 to calculate a weight limit in pounds for a person to receive an effective dose. So that is, let me reword this for you, because I agree that this question is not worded the best, okay? What it means is for one dose to be perfectly effective, not too much, not too little, what would that person need to weigh? It would be perfectly effective on a person that weighs how much? So we're gonna calculate a weight. Now, one dose, again, is how many milligrams? So we're gonna start right there. They're gonna take 325 milligrams of the drug. We need to convert milligrams of drug to kilograms of body weight, and we want to use an effective ratio. Do we have that? What is the effective ratio?
For the weight.
Yeah, for this drug to be effective, they need to be taking 6 milligrams of it per kilogram of their body weight. That is a relationship relating milligrams of the drug to kilograms body weight. So what that means is for every 6 milligrams, we're equating that to 1 kg body weight. Okay. If they take it at this ratio or in this proportion, the drug will be perfectly effective. So use that, just like you've seen me do in lecture, multiply by this relationship so that you cancel milligrams and you convert to kilograms body weight. Now you're almost there. It says calculate body weight in pounds. So once you have used the ED50 and converted to kg body weight, how do you go from kilograms to pounds? Again, you're going to use this relationship right here. I'll highlight it this time. This one right here. Okay, so you're going to multiply this by the ED50, convert to kg, and then you're going to use that highlighted relationship right up above, and you want to cancel kilograms and convert to pounds. Bye, Aaron. Part B, so that's part 7A, and you should be multiplying by, I mean, you can stop and get your answer and then multiply by the next thing if you want. So this one's going to be plugged in there. That relationship is plugged in there. 7B is the same thing, same exact thing, but instead of using the ED50, what do you need to use? It says to avoid overdosing. We know this drug becomes lethal at a certain point if you take enough of it. So we're going to use the LD50, which is this, 18 milligrams of the drug related to one, if they're taking this ratio or this amount per kilogram body weight, that's lethal. So for one dose to be lethal, and one dose is how much? 325. So again, start with 325 milligrams of the drug, multiply by the LD50, convert to kilograms, and then you're going to multiply by the relationship between kilograms and pounds to get the weight limit in pounds. Does anybody still have questions on that one? I think number 8 is the hardest.
I didn't really understand what it was asking because I know you talked about the 1.054 is that instead of.
Right.
So then I'm thinking 1.054 milliliters. Calculate how much drug will be provided in that difference.
Right. Okay. Let me explain something real quick. So this whole lab was built on this premise of let's find the margin of error. Let's figure out which instrument, a spoon, a med cup, or a syringe is the most accurate instrument, okay? Every one of these instruments has a margin of error. Every instrument has a margin of error, right? Okay, so we're human. We especially are gonna have error within our measurements when we're making them. So I told you, it said, go get your largest variation. That variation is your plus or minus error, room for error, okay? So I said it was 1.054 milliliters, okay? Because we were measuring a liquid. So we were using different instruments to measure the volume of that liquid and then go get the mass of it. That's what we did in the lab. So this variation, if this is your largest variation, this is your plus or minus. So let's say I'm using a spoon at home. I'm gonna give my daughter some medicine. And I think I'm pouring 10 milliliters in that spoon to give her some medication based on, whatever the medication is and how much I feel like I need to give her. Well, if this is your margin of error, if this is your variation, I could be giving her 11.054 milliliters or 8, whatever, subtract off 1.054 from 10. So plus or minus that. I could be giving her a little more or a little less, plus or minus 1.054 milliliters. That's a variation, okay? Now, the liquid part doesn't matter, but the fact that there is drug dissolved in that liquid is what does matter. So if I'm giving her plus or minus 1 milliliter, I'm giving her plus or minus a certain amount of milligrams of the drug, right? That's what we're trying to calculate and say, does that matter? Okay, so we need to relate how many milligrams of the drug would be in 1.054 milliliters. If that's our variation. So we need to somehow relate from the information we know about this drug, volume in milliliters to milligrams of drug. So do we have any relationships so far that include milligrams of this drug? Not the ED and the LD50. Those are standards. Those are not what I'm talking about. One dose is 325 milligrams. That's great. Whoops. All right, now we're relating this to a dose. Do we know the volume of a dose? Do we know how many milliliters one dose is? 7.5. One dose is 7.5 milliliters. We determined that the very first thing when y'all walked in. That was the first thing we determined together as a group before we got started. So I remember with all the prefixes, the milli, centi, blah, 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 when I was like, they all equal one base unit, so they're equivalent to each other. I kept saying that. So it's the same thing here. Because these are both equal to a dose, they're equivalent to each other. That's like saying 4 quarters and 100 pennies. They're both equal to $1, so they're equivalent to each other. Okay, does that make sense? So we can just make a conversion factor out of this. These are equal. So use this and convert from milliliters to milligrams. The hardest part about this problem is realizing what it's asking you and coming up with this relationship, coming up with this information. But I guarantee y'all, if I said, I want to pay for something, but all I have is quarters. It's $5 and 24 cents. How many quarters do I need? Y'all could do stuff like this. It's just the language that y'all aren't used to.
I think I'm still kind of having a hard time understanding how those two things relate to the. So the 1.054
That is our margin of error.
In volume. We're trying to figure out what the margin of error in milligrams is. Milligrams of drug. Yeah. All right. Number 9 is a multiple choice question. You can get on there and see which ones you feel like you agree with. It's just asking what the recommendations are. If you had any kind of feedback to give this company before they market this drug.
Sorry, how did you know that we were trying to find it in milligrams?
So it says, what is this variation in the drug read me the problem.
Calculate how much drug.
How much drug? There you go. What are the units for drug? Always milligrams. Again, that's where I think this question isn't probably worded the best. It could say how many milligrams of the drug. Okay, that's the lab. Pablo. Oh, would this difference matter? This is a great question. So, yeah, would it? So let's just say you calculate this and you get, oh, I don't know, 65 milligrams is your answer. That's not right, but let's just say that's it. I don't know, would that matter? So here's the way I've been talking about this with people. You have a headache, you walk into the kitchen, y'all keep your medicine in the kitchen or the bathroom. This was a huge argument between me and my husband when we got married. Kitchen! I keep it in the kitchen, okay? Why are you keeping it in the bathroom? It's weird. Okay.
Then like, why do we also, like, why do we have our laundry in the kitchen? Why is it not in our bathroom? I don't know. It's weird.
I mean.
Did you say laundry in the kitchen?
Yes, like my laundry room in my apartment
Yeah, same.
is.
Oh,
connected
that's
to the
apartment
kitchen.
life. I don't know.
My apartment.
Anyways, back to medication. So let's say you walk in there and you're gonna take some Tylenol. How do you know if you want 1 pill or 2 pills? And does it matter if you take 1 pill or 2 pills? Depends how bad your headache is, but would you overdose if you actually took 2 pills? No. But what about my daughter? When she can't swallow pills, but if she could, would that be a bigger deal if I gave her 1 pill versus 2 pills? Why? She's small. So the answer is it depends on your patient. Does that make sense?
Like on the label, like say ibuprofen, it says like it's all
Exactly. There's always like a disclaimer.
like for like if I have like a bad migraine, I'll first take 2, but if it doesn't go well, I'll just take 1.
So wouldn't that answer for number 8, the second part, like if it matters, wouldn't that answer depend on what our answer was for the weight limit for the lethal dose in 2 seconds?
Not exactly. And I don't even think I put that last clause from that question on the Blackboard assignment, but it's a really great one to think about. Okay, that's the lab. So are there questions about anything else? You what? Homework question? Okay.
I don't feel like if I read it out to you.
So that's like the final outcome of it.
How many milligrams of retention? Lithium and healthy adults contain lithium. So lithium and healthy adults. So we've got 3.2. Approximately 3.5 milligrams of CL-. How many milliliters of blood sodium do you need to get 2.8 grams of sodium? So 8 grams sodium. Chlorine plus 3. Right. You'll work that one probably the same way. We'll do this first part and see. Okay, here's the question. Which problem is this on the homework? Three point what? 3.9? Okay. Question 3.9 from the homework. So it tells you, it gives you some information on the side, and it says that in blood serum for healthy adults, you have 3.2 milligrams of sodium ions per milliliter of blood. Okay, so 3.2 milligrams of sodium ions per milliliter of blood. And blood serum in healthy adults contains 3.5 milligrams of chloride ions per milliliter of blood. And then there's a part A and B. So this is just part A down here. It says how many milliliters of blood would you need to obtain 2.8 grams of sodium? So in other words, in what volume of your blood would contain this amount of sodium? Okay. The challenging part here is that it gives you milligrams, but down here it gives you grams. So this is something that you have to recognize. What do you need to do here? You're going to have to either convert grams to milligrams or milligrams to grams, one of the two, okay? So I think it's easier to take 2.8 grams down here and convert that to milligrams, okay? So that's the first thing we're going to do. 2.8 grams of the sodium ions. We're going to convert this to milligrams. So I know I want to cancel grams and I want milligrams on top. I know that's how my units need to be. Okay. So here's the deal. On an exam, if you like freak out and can't remember relationships, if you will at least give me this, I will give you partial credit on things. Okay. And then we need to fill the numbers in. So how many grams is related to how many milligrams? 1 gram is 1,000 milligrams, or you can write 10 to the power of 3. So now we need to multiply 2.8 times 1,000. Don't grab your calculator. 2800. Now it's milligrams of sodium ions. So what we're saying, we still haven't answered the question. All we've done is saying 2.8 grams of sodium is 2,800 milligrams of sodium. That's all we've done. We're just saying this is equivalent to this. So now what can we do? I need to scroll back up. Now we can use this relationship right here, because this says 3.2 milligrams of sodium ions is in 1 milliliter of blood. There's an understood 1 here. Okay. 3.2 milligrams of sodium ion is in 1 milliliter of blood. So we're trying to figure out what volume of blood would contain 2,800 milligrams of sodium ions. So anybody have a suggestion for what we need to do here? Go for it. So I'm going to take this relationship up at the top here, cancel milligrams and convert to milliliters of blood. You can write blood there with milliliter if you want. I love to write those descriptive words in. It helps me keep things straight and remember that I'm canceling the right stuff. So here we canceled grams, and then on our second conversion, we're canceling milligrams. So you'll do 2,800 times, you can say times 1 over 3 divided by 2, or just divided by 3 divided by 2. Sorry, divided by 3.2. And that will give you an answer, milliliters of blood. Part B is going to be the same way, but it probably says, you know, how many grams of, the numbers are different, I think, for everybody. They might say like, you know, 3.1 grams of chloride ions. What volume of blood would contain that amount of chloride? You work it the same way, you would just work this one. You just work this one. But you would just use the relationship for chlorine up here instead for part B. Does that help? And remind me of your name. Gracie. Okay, we got about 12 minutes left. Time flies when you're having fun, huh? You could do this all Friday night, right? Just cancel your Friday night plans. Will you be able to come Monday? I have I don't have a formal review like this scheduled, but I have 2 office hours, one from 10 to 11, another one from 12:30 to 1:30. So feel free to come to my office. And then if you can't make those times, but you really need to meet with me, email me and we can set up an appointment outside of those times.
Can we get bonus points for that too?
Oh, yeah, we can get like 2.
No, and here's why that was not announced on the front end, and that's not fair,
But it's people that really care.
which is great. And you can go just like this for really caring, okay? I would give you a fist bump for really caring. Wow. Any other questions? I mean, do y'all need to work specific heat problems, density, prefixes? What was that, Fatima? Say that again. Specific heat problems? Okay. So again, I'm not gonna ask you to memorize specific heat values for any substance, okay? I would give you, where was that at, measurements? I would give you this table, okay, on the exam, or put the specific heat in the problem. But let's just say we're working with sodium. Let's just say our substance is sodium, okay? And okay, I'm literally making up a problem on the spot. Okay, so ignore this. I'm gonna rewrite a problem. So the specific heat of sodium is shown right there. How many grams of sodium would be heated from 15 degrees Celsius to 26.2 degrees Celsius if you apply 7,600 joules of energy. How many grams of sodium would be heated from 15 to 26.2 degrees Celsius if you apply? So these problems freak me out when I make them up on the spot because I have no idea what the answer is going to be.
Is Celsius on the left or on the, or, I mean, is calories on the left?
Oh. Let's see if I can get them. There you go. Now you can see all of it. That is 7,600 joules. So I want you to try to work this out before I do anything. You ever had a peanut butter Snickers?
Oh my gosh, yeah.
They are the best. If you don't like peanut butter, that's your own opinion, but if you like peanut butter, they are so good. And I was never a Snickers fan, ever, growing up. Sonic needs to make a blast with peanut butter Snickers. Do they even do a Snickers blast? Or Andy, or somebody needs to tap into that.
Oh. I don't know why.
All right, anybody think they have it? Jesse, right? 551.68 grams. Okay, we're gonna see if you're right or not. Okay, so how do we work this? Somebody tell me what's the first thing I need to do? Write out the equation for specific heat, okay, which is right here. Specific heat equals calories or joules. So which one do I need to mark out? I'm not using calories because I gave you joules in your problem down here. So probably one question people might have is, how do I know if I need to use this number or this number? Anybody have a good answer for that?
I mean, they're labeled.
Right, but how do you know if you need calories or joules?
Whatever it asks.
There's got to be something in the problem that either has calories or joules in it that lets you know which specific heat you need. So I'm using joules for my energy term, all right? And so I'm going to pick the specific heat that has joules in it. And what if I got really hard and I gave you a specific heat that only had units of calories in it, but in the problem I said you're applying this amount of joules? What would you do? Huh? You just convert the joules to calories or whatever to make it match your specific heat. Can you convert between calories and joules? Yeah. 1 calorie is 4.184 joules. You better have that memorized for the exam right there. So if I gave you a specific heat value that had calories in it, and then I was like, you apply this many joules, you just convert those joules to calories, no big deal, and plug those units of calories in. It got to match. There used to be a saying like the shoes have to match the dress, right? So you got to make sure the joules in whatever the energy term is in the problem, okay, whatever here is got to match the units on specific heat and vice versa.
Are you by any chance gonna put?
I can't answer questions like this. I can't answer any question about what is and is not going to be on the exam. Why would that mess anybody up? They're not scary. Why don't we, let me answer this problem, and then before we go, we'll just say, what are some things you need to make sure you have memorized? We'll make a list, okay? All right, so this will probably be the last problem we have time for then. All right, so I'm gonna use this, and I've got to rearrange and solve for grams, right? Because this equation, as it's written, says all of that equals specific heat. I'm not trying to solve for specific heat. I already have the specific heat. I'm trying to solve for the grams. So what I'm gonna do is I'm gonna say times G on both sides, times G. Now grams is on bottom, and I have it right there on top, so those cancel. I still don't have grams by itself though. So I'm going to divide both sides by specific heat. Okay. So now specific heat cancels on this side. So my new equation is grams equals joules over degrees Celsius times the specific heat. And that's the equation that I'm going to use. And I can just plug everything in now. The only thing left is I have to determine what my change in temperature is. Mallory. So if I say, show your work, yeah, show me. Well, you could just write that equation, as long as you have the right equation. No, as long as you write the right equation. But then show me all your work of plugging things in and canceling units and all that. Okay, so now we have 7,600 joules on top. So grams equals the joules divided by the change in temperature. What's the change in temperature? 11.2 degrees Celsius times the specific heat, and we need the one with joules, so 1.23. And it's joules per gram degrees Celsius, right? What? Tania, do you have a question? What I boxed in, the 15 and 26.2, we just figured out what the difference is. We did 26.2 minus 15. Equals 11.2. All right, so now 7,600. So in your calculator, I put this in parentheses on the bottom. When you're dividing by multiple things, just put them all in parentheses if you're going to do it all at once. 7,600 divided by 11.2 times 1.23. What do you get? Do you get 551.68? Okay. Jessie does get a sticker on her exam. Okay. you got the right formula, then it should be pretty easy. You just plug everything in. I mean, there's only so many ways I can ask you specific heat questions. I've got to give you 3 of the 4 terms, and you're just solving for the 4th, okay? So again, remember, there's two styles of problems, really, overall. There's equation problems where you have an equation and you're plugging things into equations, solving for a variable. Then there's conversion problems where you're starting out with some information with a particular unit and you're trying to figure out what the equivalent is in another unit, okay? And just converting, all right? Based on certain relationships and conversion factors that you either will be given or have to kind of piece together. So what do you need to have memorized? That's the last thing we'll go over. Oh, for sure. So polyatomics. No, the prefixes. Which one? So prefixes. You need to know kilo and its relationship to the base unit. Centi, its relationship to the base unit. Milli. But I know y'all all already have this memorized. So micro, whoops. And nano. Okay. That's not it. You do not have to memorize the periodic table. You need to have the trends of the periodic table memorized, right? In ionization energy, atomic radius, electron affinity, those are the 3 trends we talked about. Okay. There's 3 of those: ionization energy, atomic radius, electron affinity. You need to know the conversion between Kelvin to Celsius and vice versa, degrees Celsius. Know the relationship for calories and joules.
You said you were gonna provide Celsius to Fahrenheit.
Right. You need to know, the equation for specific heat.
We need to memorize like which are the alkali, the halogens, you know, that stuff.
Oh, yeah. I mean, honestly, this list is kind of, could go on and on. If we discuss it in class, it's fair game for the exam. Okay, so you need to know atomic structure. You need to know Dalton's atomic theory. You need to know how to classify matter, the difference between a compound and an element, and a homogeneous and a heterogeneous mixture. You need to know the 4 signs of a chemical change. You need to know the difference between chemical and physical changes. You know how to write ions and ionic compounds. Okay. All right. Well, thanks for joining. I hope it was productive.